We are group number 6. I am Wyatt Weining. I am here with my teammates Chandler Callejo, Elise Flachs, Brian Kappenman, and Russell Phillips. We are going to be discussing our line racing robot for the term project for Mechatronics. Our goals was to follow a track that is marked by a black line on a white surface. Along this track, there is to be a sequence in which our robot enters a ranging algorithm. This is to occur at a dashed line that is perpendicular to the track, upon which it is to face an object on that track and determine the range that that object is positioned at. Every 5 centimeters that the robot is off will result in a 5-second time penalty. It was determined that the fastest of 3 laps would win this competition.
So we split up the work into 2 main areas of focus, being the report and the robot. Each member was able to spend some time working with both the report and the robot in either the building, coding, or troubleshooting, and report writing as needed. And we were able to do this in a relatively short amount of time.
So we implemented the design methodology as outlined in the textbook for this course, and there's 11 steps. And basically what it is, it takes a top level approach as far as design goes. You look at the system requirements, and then you kind of trickle down the requirements of the components so that you design the components around the system requirements versus optimizing the components for the components purposes. As far as signal conditioning and computer interfacing part of this project, this is a photo taken from Lab 7, just so you can see the point. As you can see, there's for signal conditioning, we used a moving average filter, so it smooths out the data points, as you can see between the left and right photos. This helps remove kind of noisy data, which could cause the robot to detect something that isn't there and cause it to act in a non-ideal way. And we did this for the analog line sensors that we implemented to detect the course that it was put on.
So for the actuator and transducer selection, we chose ones that we'd already used in lab because we were familiar. So for the actuator, we used a DC gear motor. And the main reason was it was really cost effective, as both of the motors were extremely cheap. They were easy to mount onto the robot chassis, and then we could use them in junction with the H-bridge to control the direction and speed. For transducers, we used a line sensor and an ultrasonic distance sensor. We used 4 line sensors as they were very applicable to this competition. 2 were in the front of the robot and 1 was on each side. They were extremely small and lightweight and easy to mount, making them very useful for this competition. And then in terms of the ultrasonic distance sensor, this was used for ranging that object that Wyatt mentioned throughout the course. And so this gave us really accurate feedback, and it was easy to mount on the front of the robot, so it turned out really well for us.
So this is an image of our final prototype. And of course, everything is ran through an Arduino Uno. And the motion it happens through the H-bridge, which you can see there, indicated with the circle. And then we've got 4 line sensors on it. There's 2 in the front and then 2 on each side, and you can see those with the green arrows. We also have an ultrasonic sensor on the front, and that ultrasonic sensor senses distance, and we have some LEDs on the middle of our robot, which through a pattern, it indicates the distance, so it does an output of that distance. As you can see here, this is kind of a video of our competition. So some of the rules you can see there, but we already covered some of those. But how our robot performed, we got a time of 1 minute and 40 seconds. And for each of the distance readings we got, on the first lap, we got 31 centimeters. Second lap was 32 centimeters. And the third lap was 31 centimeters. And the actual distance was 33 and 1/4 centimeters. So we were within that like 5 centimeter range where we didn't have any sort of penalty for being like 5 centimeters off from that distance range. So that was really awesome that our robot was able to do that and perform well on its time.
And one of the main goals of this project was to be able to relate it to the ABET outcomes that we are using in class. We were able to solve this complex idea of a robot that is able to follow a nonlinear line. We were able to use we were able to relate the project to what could be useful in the real world. We were able to communicate effectively between members and people outside of the project in a way that would be understandable. We were able to recognize the ethical and professional responsibilities that are required of engineers. And we were able to function effectively as a team without any interference between team members or problems between team members and the project.